Good morning, everyone, and welcome to mentorship session number 3 of the CZITT AI Energy Hackathon. It's a pleasure to have you all with us again as we continue building your understanding and strengthening your ideas. Today's session is especially important because we are focusing on energy fundamentals, the very foundation of the energy solutions you are being challenged to develop. As you know, this hackathon is not just about ideas, it's about real data driven solutions that can make a measurable impact in how energy is used and managed across Trinidad and Tobago. So I want to encourage each of you to stay engaged, take notes, ask questions, and most importantly, start thinking about how today's knowledge connects directly to your project concept. You are not just participants, you are problem solving in training. And the work you are doing here truly matters. So this morning, we are honored to have with us a distinguished expert in the field of energy and electricity systems from the Trinidad and Tobago Electricity Commission. Dr. Curtis Boodoo is here with us, and he is assistant professor of the University of Trinidad and Tobago and commissioner at the Trinidad and Tobago Electricity Commission. So at this point in time, Dr. Boodoo, you're on.
Thank you so much, Claudette. Let me say good morning to all our listeners, and a special thanks to the CZITT team and the other stakeholders for organizing this event and having me here. So I'm delighted to be with you this morning. I will be chatting about the electricity sector, the electricity network, and providing some fundamental background on our electricity sector. Some of the topics, to be honest, that I will cover today is a bit advanced, and you could find them being taught easily at bachelor level studies or even postgraduate studies. But I will be exposing you to these concepts early on, and I will be relying on my many years of teaching experience to break down these advanced concepts into the fundamentals so you could properly digest it in the very short session we have. Why should we focus on the electricity sector? So we are aware of climate change. Climate change causes rising sea levels. Climate change causes more powerful tropical cyclones, hurricanes. Climate change even causes more diseases because of the hotter ambient temperatures. So why is there a focus on the electricity sector? So on your left, if you look at, so let me annotate. So this pie chart, or if you want to call it a donut chart, represents the breakdown in global emissions. So this is not the emissions for Trinidad and Tobago, this is globally. Global emissions, and I believe the year this data is for 2023. So global emissions, around 77% of global emissions were due to the energy sector. And then the other sectors would be agriculture, industrial processes, etc. So if you focus on the energy sector, which makes up 77% of emissions, and you look deeper inside that energy sector, you will see that electricity and heat generation account for 34%. So in the energy sector that accounts for 77% of all emissions, the electricity sector comprises or accounts for more than one third of those emissions. So it is one of the sectors with the most emissions. Next, the electricity sector is transportation. Why should you care Okay, so the electricity sector globally is responsible for quite a lot of emissions. It is the largest sector associated with emissions when you break it down. Why should I care about that? You know, that's an interesting question to ask. So that's a relevant question to ask. This is Trinidad and Tobago in 2050. If the rise in global temperature is around 1.5 degrees. So what you're seeing here is what you're seeing in blue are locations that will be below sea level. So in the year 2050, if we are able to reduce stop the overshoot of the rise in temperature of around 1.5 degrees, you could see there are certain parts of Trinidad that would be under sea level, mainly towards the east, Port of Spain. This here is our main highway. So that is Bamboo Settlement, etc. And then we have in the south of Trinidad. The issue here is we will most definitely cross 1.5 degrees Celsius. We're not going to be able to meet that cap. That's why I used the word overshoot before. So we accept we are going to overshoot the 1.5 limit, degree Celsius limit. So we have to bring it back down. This is what happens to Trinidad at the end of the century, 2100. It is unlikely I will be here at that time. You would be here. You would, of course, be in your golden years, as we put it. But this is what Trinidad and Tobago looks like. Well, Trinidad looks like at the end of the century. If we have a 5-degree increase in global warming, where our capital is, where St. Joseph, where Curepe is, all of that area will be below sea level. We lose most of the east coast of Trinidad at the end of the century. Our southwestern tip, we lose the sea level rise. And it goes along throughout the entire coastline of Trinidad. This, ladies and gentlemen, is the effect of climate change. And it is important for a small island developing state like ours to be vocal and try to bring about global change to help reduce this rise in temperature that will bring about a rise in sea level. So at 2 degrees Celsius, this is what you see. And of course, at 4 degrees, it is more drastic. What temperature would we eventually reach? Well, there are a lot of climate projections. We're not sure yet, but more than likely, it's going to be between 2 degrees and 4 degrees. So our situation at the end of the century would lie somewhere in between both these graphics. So that answers the question, why should I focus on the electricity sector to reduce emissions? Well, you see the effect of climate change here. And we just said that the emissions from the electricity sector is one of the most significant sectors globally. So it's a sector that we should focus on. Let's talk about some basics as it relates to electricity, because we're going to talk about the electricity network. So we need to know some basics. Sometimes it could be difficult to visualize electricity. And the analogy I like to use, at least for my class, is for them to think of electricity as water. Flowing water through your pipes. So you have your domestic pipe, so you have water coming into your home. Think about electricity like that water flowing through your plumbing. Some of you who did science, or probably from Form 1 to Form 3, or if you're studying science with CZITT or even CAPE, you would know voltage, current, and resistance, and you will know the famous Ohm's law. So using the analogy of a pipe with water, you could think about voltage as being water pressure. So the greater amount of voltage, when I say something has a high voltage, it has a high pressure. You get to move a lot of water. So you could move a lot of current because you have a high voltage. And think about current like water that flows. That's the amount of water flowing, right? You could think about current like that. And resistance, you could think about resistance as being a blockage in your flow of water. So that's the easiest analogy I would use for you to understand voltage, current, and resistance. Relate it back to water flow, something that's practical to you, right? So voltage is pressure. Current is the volume of water or the water itself that's flowing. And resistance is you could even use the same word resistance, the water flow in your pipes. There are two types of power or voltage and electricity that you are exposed to. There's DC current and alternating current. DC current, the current and the voltage, they represent a straight line, as you can see here. It's a straight line. AC current, which is the signal, the electricity power that reaches your home, it's a sinusoidal waveform or sinusoidal waveform. So you would have covered sine wave and cosine wave in mathematics. So this is what your electricity supply looks like in your home. So one is alternating current and one is DC current. Where do you have DC current? Your cell phone battery, the energy is released as DC and it's charged using DC current. In fact, it's any battery. So it's your cell phone, your laptop, what other device you use that has a battery? Cell phone, laptop are the most common ones. Your tablet, that uses DC. So most of our consumer electronics today uses DC power. So you use two different types of power in your normal day. AC power, which is in your home, and DC power in your devices. You could convert between AC and DC, and you already use devices to do that. Your laptop charger converts the AC in your home to DC to be used by your laptop. Your cell phone charger converts AC in your home to DC to be used to charge your cell phone. So you already own devices that convert from one type to the next. Well, so why do we distribute electricity as AC power? Well, it's more efficient. It's more efficient to do it. The technology that we use is mature. We save energy by transmitting in AC, right? So our electricity grid is one where you have your power generating plant. This power generating plant will generate electricity with a high voltage, and then that electricity goes to a transformer. I enjoy all the transformer movies, but it's not that type of transformer. It's the transformer that you would find outside your home. This is an example. I don't have an image here, but the transformers that look like a cylinder that's on your pole outside your home, that transformer I'm talking about. So this transformer raises the voltage value because this power has to be transmitted this power has to be transmitted along long distances. And it's more efficient to transmit power at a high voltage because you use a lower current and you get losses, right? So it's better to transmit power at a very high voltage for long distances. And that is the purpose of this transformer. It takes the voltage from the power plant, it steps it up, and then you bring that power on your transmission lines. So when you drive along the highway and you reach the Carney Bird Swamp or other areas on the highway, you see these very tall towers. that carry the electricity lines. Those are called transmission lines. The tower outside your home or the pole outside your home is not as large. The pole outside your home is much smaller. It has these specialized cylindrical transformers, right? So those are transformers as well. But the pole outside your home is called distribution network. So the electricity that comes to your home, your neighborhood, those are what you call a distribution network. And it comes after the transmission network. So the transmission network carries voltages at a high value. We then come to a substation, it breaks it down, and then it comes to your home. So let me do that one more time. Power generation. Then we have a big transformer that steps up or raises the voltage because it's more efficient. And we take that high voltage and we transmit it in a transmission line, which covers great distances, and it's a vast tower. That transmission line comes to a substation, which breaks it down to a voltage that you could use, and that flows through the network that you see outside your window or in front of your home or in your area. So that's a description of the electricity network. Now we talk about some of the advanced topics I wanted to introduce you to. In Trinidad, we use natural gas for power generation. In Tobago, we use natural gas with some diesel, right? So you would hear a lot of people saying, well, Trinidad is 99% natural gas generation. I'm not sure about the exact figure, but it's mainly natural gas. So all the generation in Trinidad is natural gas, but for Tobago at the Cove power plant, we use both diesel and natural gas. And there are reasons for that we will not cover today. How much percentage of our natural gas do we use for electricity? That's an important question because natural gas is a vital raw material. We use it, we export it to gain revenue. So if you want to use as less or as little natural gas for power generation, because you want to take most of it and export it to earn foreign exchange. So that is the principle here, right? So if you look at the plot on your right, on the x-axis, I have months and years, y-axis is percentage. So on average, you could say we use around 12% of our natural gas for power generation, right? 12%. This graphic on the left shows the other sectors. Most of our natural gas is used as LNG, but we are using around 12% for power generation. How does well, we spent our entire lives living in Trinidad, but do you understand how the electricity landscape works in Trinidad? If I ask you about electricity, you will say, well, T&TEC gives me electricity and we pay them. And that's fine because that's your interaction. Well, your parents pay them. So you get electricity from T&TEC, your parents pay the bill. That's what you know of. But it's a little more complicated than that. So T&TEC operates what is called a tolling system. Just like you pay a toll to cross a bridge when you go abroad, or you pay a toll for whatever transport, we operate what is called a tolling system. We hire power generation companies to change natural gas to electricity for us. We hire them to do that, and they use our network to distribute the natural gas, to distribute the electricity, sorry, to you, and we collect money from you as payment. So let me say that one more time. T&TEC operates a tolling system. We pay power producers to convert natural gas to electricity. That electricity comes on the electrical network. It comes to your home and you pay us. That's a simple way of looking at the electricity landscape. Now, let me add on some layers of complication. In Tobago, T&TEC owns both. We don't own power gen, but we own 51%. So we are the majority shareholder. We don't own the TGU power plant in Labre, and we don't own the Trinity power plant, which has been renamed recently. So that ownership kind of complicates it, but the framework or the design is the same. We operate a tolling system, just like how you want to cross a bridge, you have to pay a fee. So natural gas is supplied to the independent power producers. We pay them to do that. We distribute the electricity and you pay us back for that electricity. I'm cognizant of my time. This is what we call the demand curve for Trinidad and Tobago. What is the demand curve? This is how much electricity Trinidad and Tobago uses throughout a typical day. I have 3 plots here representing 3 different years. Blue is 2017, almost 10 years ago. Orange is last year, and green is data from this year. Limited data for this year for a few months. On the y-axis, I have power, megawatts. That's the unit for power. The unit for power is watts, right? Named after James Watts. But megawatts, millions of watts, because you use a lot. Typically, we use around, I think it's around 1,300 megawatts now. That's the highest demand we would use in Trinidad and Tobago. So let's look at the shape of the curves. So if you look at the blue curve and we move into the orange and the green, you could see that there's a rise or vertical upliftment of the blue curve, meaning that our energy use is increasing. In 2017, we were using a certain amount of power. In 2026, we are using more. So the curve went higher, which means that the values in the y-axis increase. So that means that we move using more power. That's a natural thing. It's natural because you have population growth, you have more economic activity. But what is not natural about it is also due to climate change. You use more air conditioning now, or for you to air condition a space, you need more energy because the ambient temperature outside is more hot. So a lot of our additional load during the day is due to air conditioning. And on the x-axis, you could see the hours of the day. This is a 24-hour clock. The concept I want to introduce you to is this. The peak or the time of day which we require most of the electricity is around 7 p.m. This is 7 p.m. And then we have another daytime peak, which is around midday. Those are the times Trinidad and Tobago use most amount of electricity. So at 7 p.m., everyone is home. I used to say people turn on the news and watch, but people don't watch the news anymore. So you use your social media or you on Netflix, etc. You're having dinner with your family, etc. So your lights are on. You're using lights, you probably doing some washing, you cooking. All these activities take place in your home. And it's industry as well. At the middle of the day, air-conditioned systems running in workplaces, commercial entities are operational, manufacturing plants are operational. So you have a peak value at the middle of the day and at 7 p.m. The problem is these peak values contribute to climate change. How? Well, they contribute to climate change and they are expensive as well. Why is that? Imagine you drive in a car. You don't have your license yet, right? Probably too young. So imagine you're watching your parents drive a car. Every time you accelerate, you burn in gas, you burn in more gas. So it's very inefficient. If you are a person, you know, the phrase we use in Trinidad is heavy foot. If somebody have a heavy foot, meaning that you as soon as you see room in front of you to drive, they mashing that X and driving and mashing the brakes as well to stop. If that is how you drive, well, or your parents drive or whoever you see drive, that's a very inefficient way of driving. Not only is it not safe, you're burning a lot of your gasoline. Because every time you mash that X and you accelerate, you want a lot of power in a short space of time. It burns more gas than if you drive at a steady speed where you keep the accelerator at a steady speed. It is the same for the power plant. So at 7 p.m., just like when you drive in your car and you like to accelerate the short distance and then stop, at 7 p.m., the power plants have to provide power and a lot of power at a very short space of time. So it burns, the power plants burn more natural gas because you come home and you put on all your appliances and everything is in use. When you burn more natural gas, then it costs the country more and it contributes more towards emissions. So the goal in the electricity sector is to reduce these peaks. If we reduce these peaks, we save natural gas and we reduce emissions. How do you reduce these peaks? You plan your electricity usage. That's a difficult concept for us in Trinidad because electricity is cheap. So you don't plan your electricity usage, you just use. You put on things, you don't schedule them, etc. So that's one of the main drivers why we have those peaks. And how can you help climate change? You can reduce the amount of appliances you use after 6 p.m. or around 7 p.m. Right? So if it's not too inconvenient for you, your parents and your family, you reduce the appliances you use. Then that will be your contribution towards climate change. I probably went over my limit already, but just quickly, the electricity grid is changing. You have your traditional electricity grid, which we currently have, where you have power generation plants, and these power generation plants distribute power all the way to you. So power generation plants are centralized, they're far away from most communities, and we use transmission lines to bring that electricity to you. The modernized grid or the smart grid is one where electricity is generated in your home through solar panels, mainly, or electricity is generated at your school or your commercial business area. And that electricity is consumed on site most of the times. So the electricity network changes. It changes from these big power plants that deliver electricity from far away to a system where electricity is generated on site and consumed on site. And this electricity is clean electricity. You don't put a natural gas generator in your home, you use solar, right? Solar, small wind energy. So that is the evolution of the electricity network. I could cut my time here. Thank you for listening. And if you do have any questions, you could send them or ask them, and I'll try my best to get back to you. Thank you so much.
Thank you so very much, Dr. Boodoo, for an excellent session. I'm positive that participants truly appreciate. I do have one question I would like to ask you.
Sure.
At my school, the lights are always on and sometimes the air conditioning, even though nobody is in the room. Can we make them automatically turn off?
Yes, you can. There are so for the lighting, So you said so the AC unit would be a bit of a challenge because it requires a switch that handles more power. For the lights, it's easy. There are timer switch that you could easily get an electrician to install, and the light will turn off and turn on for a certain period. In fact, on Amazon, you could buy a switch. It looks like a small box that you plug in your existing outlet, and it has Wi-Fi. So you have an app. I own one. This is how I know it. You have an app, and in the app, you go and you set the time in which this switch will be live with power. So if you connect your fan or any device on that switch, but you set the schedule using your app, it will only be powered at that time. So that's a smart way of doing it. For the AC units, you could use a similar device, but you're using a little more power. So it will cost a little more, and you will need an electrician to install that one. But most definitely, there are smart devices that could automatically control the load on and off.
I know we are almost really out of time, but I just have one more question for you from another student. Why do we not use more solar power in Trinidad and Tobago? And I think this is a good question for you.
Probably need an next half an hour for that.
No.
Excellent question. Why don't we? So you can. And I would encourage, so electricity is cheap for the domestic user. But if your household is one where you belong to the middle class of Trinidad, meaning that you have finances available to you, you have some extra money at the end of the day, you can invest in solar. And I encourage you to do that. It's actually not all that expensive anymore. Solar PV prices have dropped in Trinidad, battery prices have dropped. So you can, if you want to make that investment. So it's an investment decision made by the household. If you're not one of the middle class or upper class households and you don't have access to this extra funds, then you're happy using the cheap energy, and that is okay. That is okay. You're happy using the cheap electricity. So that is one of the main reasons why. But it doesn't really answer the question for commercial users. Why aren't commercial users deploying solar? So the sector is new in terms of the deployment of the technology locally, and it will get better with time. That's a good question, and that's my shortest answer.
Okay, so thank you once again, Dr. Boodoo, for a very insightful and practical session. Participants, what you've learned today is not just theory. It is the foundation for the solutions you are building in this hackathon. As you continue your work, think about how energy is used, where it can be improved, and how your ideas can create real impact. So once again, stay focused, stay collaborative, and keep pushing your ideas forward. Thank you all for staying on for the extra time, and do have a great day.
Bye.
Goodbye.